So starting with the original equation, 6 over secant x plus 1 minus 6 over secant x minus 1, we first have to get the least common multiplier. So we multiply the two denominators together, and then we multiply their product across the equation. So then we get 6 times secant x plus 1 times secant x minus 1 all over secant x plus 1 minus 6 times secant x minus 1 times secant x plus 1 all over secant x minus 1. This allows us to cancel out the bottom secant x plus 1 and the top secant x plus 1, and it allows us to cancel out this bottom secant x minus 1 and the top secant x minus 1, which leaves us with 6x, or 6 times secant x minus 1 minus 6 times secant x plus 1. And because we multiplied both the top and bottom through by secant x plus 1 and secant x minus 1, the bottom part of the equation is now secant x plus 1 times secant x minus 1. And in the next step, we take out the common factor on the top of 6 times secant x minus 1 minus 6 times secant x plus 1. So we took out a 6. That leaves us with 6 times secant x minus 1 minus secant x minus 1. And that's all over the product of secant x plus 1 and secant x minus 1. This makes a perfect square. So secant x times secant x is secant x squared. And then it's minus secant x plus secant x, so those two cancel out, minus 1. So this is what's left on the bottom. And this is also equal to tangent squared x, because secant squared x minus 1 is equal to tangent squared x in just the set tangent or trig properties. Then we cancel secant x and negative secant x. And then negative 2, or negative 1 minus negative 1 is negative 2. Negative 2 times 6 is negative 12. So the final answer is negative 12 over tan squared x.